this video, we are going to see a question on isometric projections. For that, here we have the diagram which they have given. It is said that figure shows two views of an object. Draw its isometric view. So the two views are given, that is front view and top view, and we have to draw the isometric view. It means the 3D diagram, that is the conversion of 2D into 3D is called as isometric drawing. So by looking at the front view and top view which they have given, we have to plot the complete object, that is complete 3D diagram. Now, whenever we have such a question, the first thing we should note down is the total length, height and width of the object. So when I am looking from the front, in that case, if I want the total length, because in the front view the length is seen, next even in the top view the total length would be visible. So if in the front view I am not getting the details of the length, I can look into the top view, and now when I see in the top view, here the length is 75 mm, and from this center up to this end the radius is 35 mm. So 75 plus 35, that gives me the total length as 110 mm. I'll write it down. Then total height, looking into the front view, the height is 100 mm, and the total width, if I look at this object, because width is not seen in the front view, it will be there in the top view. So when I look at the total width is corresponding to this height, which is nothing but, I can say it is the diameter of this semicircle. Radius is 35, so diameter is 70, and that 70 width is going on continuously, so that will become the total width. Now once I have the total length, height and width, I'll start explaining the drawing step by step. Here I am drawing a light horizontal line. Next, selecting a point here, I'll measure 30-degree angle on both the sides. So drawing light lines inclined at 30-degree, because in isometric projections we have the surfaces which are inclined at 30-degree. From this same point I am drawing a light line which is perpendicular exactly, so a 90-degree line. Then here I'll say this point is origin, because in case of isometric projections the origin is required. And now I have to adjust the drawing in such a way that length, height and width should be fixed. And where to fix them? Here the origin is given, it means this corner will be close to the observer. So when I take this front view and keep it on the origin, then the length is going to come on this side, because the object will be tilted around the origin. If the origin would have been at this corner, then taking the object, keeping it here, in that case the length would have been over here. But here, as per the direction of the origin, I have to take the total length on this side. So I'll mark the total length, which is 110 mm. Now the total height is 100 mm, so I'll be marking the total height here. Joining these points. Then the total width is 70 mm, so width would be marked on this side. Then through this point I'll draw a parallel line parallel to the width which I have marked. Now over this line, like I have made it parallel to the width, I'll mark 70 mm, joining these two points with the help of light line. So here I am getting another surface. Next, projecting a light line parallel to the length. Over this, I'll mark the length 110 mm. So here I'm getting this block. Now inside this block, the diagram should be drawn, or it should be completed within this. And how I am going to proceed in this drawing, I'll explain step by step. Like for example, if we look at the drawing in the front view, then here we are having a plate which is a horizontal plate having height of 20 mm. Next, there is a vertical plate whose length is 25 and it is having a total height. I can say that total height is 100, but if we measure from this 20, it is 80 mm. So I'll divide this drawing into the two plates or the two blocks. One block is horizontal, another block is vertical. So first, to draw this horizontal block, I require a height of 20 mm. So for that, height are measured on the vertical lines. So here I am taking 20 mm, then even 20 here, drawing light line. Next, I'll measure 20 over here as well, joining them. So drawing a light line. Next, over this, I'll be marking the total width, which is 70 mm. So I'll just take the distance 70 and then joining these 2 points to get the complete surface. So after getting this surface, I'm joining these 2 points. Next, so this is the horizontal plate, and for the vertical plate, this plate is having a length of 25 mm. So measuring length as 25. Even on the other side, I'm measuring 25 mm, joining the points. Next, drawing light vertical line as well as from here, light vertical line, joining the points. Now, this is the vertical plate or the vertical block. So inside the horizontal block, I'm going to draw the portion which they have given. Similarly, inside the vertical block. So completely, I have divided this whole block into two simple blocks, horizontal and vertical. Inside this, I'm going to start drawing. Now, when we look at the horizontal block, it is having a semicircle, and that semicircle I would be drawing it first. Here, the radius is 35 mm, so the diameter becomes 70 mm. So it is starting exactly from the right hand side, that is the length is from right hand side. It means from this side I am going to measure the diameter of 70 mm. Like here I am measuring 70, even here, joining with the help of light line. Now inside this surface I have to draw the semicircle, and here I am explaining the method to draw the semicircle, because in case of isometric drawing you cannot directly take the radius or diameter or start drawing the semicircle. The process is little bit different that I am going to explain here. So once we get this parallelogram which is having 70 mm width, 70 mm length, inside this, to draw the semicircle, first I have to connect the longer diagonal. That is, if I see here, when I join these 2 points, that's going to give me the longer diagonal. Then after getting the longer diagonal, I'll get the midpoint of each of the side. So here I have 70 mm length. I am taking its midpoint at 35 mm. Now after getting the midpoint, in order to draw the semicircle here, the next thing would be to join the midpoint here, which is at the top, to the bottom opposite corner in such a way that it will be cutting the longer diagonal. So I'm connecting this midpoint to the corner, its opposite corner, cutting the longer diagonal. Similarly, bottom midpoint to its opposite corner, again cutting the longer diagonal. Next, once I have drawn these lines, so with the help of these lines, here I am getting a center. Next, I want semicircular portion, not a exact complete circle, but a semicircle. So for that, I am joining these two midpoints. These two midpoints will be acting as the limits, that is inside which the semicircle should end. So from this, I am drawing just a light line. Now, to draw the semicircle, taking the center, which I have marked here, and measuring the radius, drawing a light arc joining these two midpoints. Next, I want semicircle only up to this point, that is the limit. So I have to take the center in such a way that I get an arc here. For that, I am taking this center, because if I take the opposite center, then I would be getting the arc in the opposite region, so that is not required because we want the semicircle here. For that, I am taking this center, then measuring this radius and joining them with the help of light arc. So here is the arc or the semicircle. Then this semicircle is having a height of 20 mm. Like one semicircle is there at the top, another is there at the bottom. So I have to draw another semicircle in a similar manner. So for that, I'll be projecting the points downwards, getting this point downward. Next, similarly, where the semicircle is cutting the longer diagonal, getting that point also down with the help of light vertical line. Next, the center point or the midpoint of the side of the parallelogram, that will also be projected down. Next, the center which I have used, that will also go down with the help of light vertical line. Next, the other center which I had used, this one, that should also go down because I have to draw the semicircle at the bottom. Then here the depth is 20 mm at which I have to draw the semicircle. So I have to measure 20 mm exactly at the center which I have used. I am taking 20 mm here, and then taking the same radius, going 20 mm down, that is the center has been shifted now, drawing a light arc, then taking this center also 20 mm down and measuring the radius which I had used previously, or in other words, I can take this center 20 mm down, taking the distance up till here, joining with the help of a light arc. So this is the semicircle I am getting. Now once I have drawn this semicircle, I can directly make it dark because it is visible. So here I'll make these semicircles dark. Now once I have drawn the semicircular part, both the semicircles are joined. So here drawing a light vertical line connecting them, which I have already drawn. Next, making this line dark. Then inside the semicircular portion there is a hexagon of side 20 mm. So in order to get the hexagon, here I have the center of this semicircular part. Now hexagon is having 20 mm side. So for that, here I'll draw a parallelogram of 40 mm, that is double the side. So measuring for 20 and 20 on both the sides. Here through this point I am drawing a parallel line, light parallel line, another light parallel line, light line through the center. So here I have drawn a parallelogram of 40 mm side, that is, since the side of the hexagon is 20 mm, so here for the parallelogram we have to make it double, because hexagon is drawn by taking the radius as equal to the side of the hexagon. So side is 20 mm, that is the radius, so diameter of the circle will be 40 mm. In a similar manner, here the parallelogram is having sides as 40 mm. Now, as per the orientation given, taking this as 20 mm and then joining it as per it is given in the question. So this is the hexagon which I am getting here, and that hexagon is having is side here, so I have drawn the side of the hexagon here and the corners are at this location. Now I'll make it dark. So this is the way the hexagon should be drawn in case of isometric projections, that is inside the parallelogram. Then this hexagon is 10 mm deep. It means it is not throughout, but it only goes down by 10 mm. So I have to bring this hexagon down up to a depth of 10 mm. So for that I would be projecting light vertical lines. Now measuring 10 mm and then drawing a right parallel line. Next, through this point another parallel line, and then here also I have drawn a light vertical line. So from this side another parallel line only up till here. Now this surface of the hexagon will be visible, so I would be making it dark. So in this way the hexagon is seen in case of isometric projections. Now once I have completed it up till here, the semicircle is being extended up to this vertical surface. So drawing light line connecting them, and at the bottom as well. Now here this vertical surface is a sloping surface, as can be seen from the front. It is having a height of 10 from one side, that is, I'll explain. From this plane I'll be measuring 20 mm down, 20 mm down, and connecting to this corner as it is connected to the total height 100. Measuring 20 mm and 20 mm, joining it here and even here. Next, these 2 points are connected so that the slope is formed. So now here, after completing this, I can see that there is a cut which is visible from the top. Now this cut is having an angle here of 60°, and as I can see, this dimension is 20 here, but on the other side the dimension is not mentioned. So when you don't have this dimension, they have given the angle, and when the angle is given as 60° of this surface, and from here also it will be 60°, then that 60° I won't be measuring it directly, but I would be measuring it on a separate drawing here, because if I take 60° directly here, these lines they are already inclined at 30°. Measuring 60 directly over here will give me the angle as 30 plus 60, which is 90°. So in isometric drawing, if they give you any angle other than 30°, or I can say that if any of the angle is given, then you cannot directly measure it onto the drawing. You have to draw it separately and then bring it here. So for that, what I would be doing here is, first I'll get the center of this slope having a width of 70. So drawing a light line. Next, here this portion is having a length of 12 mm. So that length 12, it is a very important step which I am explaining. Length 12 will be measured on this line which is 30° incline, and then I will bring it back onto the slope. measuring 12 mm and then projecting it light. Now here I get this point on the slope. This point will be projected back up to the end. So getting this line, now over this line the cut will be there, and as I have mentioned time and again that if the angles are given in isometric drawing, it is better to draw them or draw it compulsorily in a separate diagram and then project it back. So for that I'm drawing that surface on a separate view here. Now here this complete surface is having a length of 25 mm, and for that purpose I'll be measuring 25 directly over here, measuring 25 mm. Next, it has a width of 70 mm, so I'll be measuring 35 mm from one side, 35 on the other, so that gives me 70 mm. Then here this indicates length and this is the width. It means I have turned this object here. Now if I take from the top, 20 is the width, so over this width of 70 from the center I am marking 10 mm on one side. This is from the center, 10 mm on one side, 10 mm on other side. Then after taking a length of 12 mm there is an angle, so I'll take the length over here as 12 mm, projecting light line. Now I need an angle here. That angle is 60 degree. So if it is 60 degree, for that case I'll keep the protractor here. From here I am measuring the angle as 60 degree, joining it with a light line. Next another 60 degree I'll measure from other side. Now this is the surface which I am getting. I'll quickly make it dark and then copy it onto this drawing. Now this surface, and here I'll mark its center. This surface is also called as dovetail. Now this dovetail needs to be copied here. For that I'll measure the distance, that is 20 mm, which is the total distance. So from the center up till here it is 10 mm. Copying this on the slope, then this distance, and here as I've mentioned this was 12 mm length projected onto the slope. Now over this line I have to mark the distances for this dovetail projection. Now these are the 4 points which I am getting, so connecting them light. So this is the dovetail projection which I am getting. Now as it is seen from the diagram, this dovetail is hidden here in the front view and it is throughout. It means it is throughout the height. For that I'll have to draw a vertical line through this point. Next, once I have completed this, I can directly make it dark. Joining all these lines to get the complete surfaces. Now here if we see the drawing, it has been completed and we don't have to give the dimensions here. So this is the answer to the question which they have given. Here I have drawn the isometric projection as visible, and with this we complete the problem.